Hello and welcome to the next episode of Python for Chemical Engineering Calculations. In this video, I'm going to talk about working with NumPy arrays, basic mathematical operations with them. So we're going to do it in console, and we're going to start with importing NumPy and creating a couple of arrays. So my array A would be in NumPy array, be a 2x2 array of following elements 1, 2, 3, 4, and I want to make it a float. Let's run that, and we see this array has been created. We can look at it here. And an array B, which will be an array of ones of the same shape as my array A. So it will be ones like A. So we can add, subtract, multiply, divide, and so on these arrays as if they were just regular numbers. All these operations will be performed element-wise. So I can do A plus B, and the result will be, well, it's going to be a 2x2 array, and each element of this array would be a sum of the elements of A and elements of B in the corresponding places. So we can do A times B, and again, this is element-wise multiplication. It's not a matrix multiplication, although Python of course can work with matrices. However, this will not be covered in this specific video. We can do A divided by B, and we can also introduce an array with C, which is twice the array A, and we can look at our C here. So each element is twice the elements of A. And we can do something like a modulo operation, modulo division, A divided by C, or A divided by B. In addition to the arithmetic operations, we can actually perform some logical operations on arrays, and they will be performed also element-wise. Let's say I want to look at my array A, and I want to check which elements of array A are greater than 2. Well, and it will return me an array, a 2x2 array with 2 elements being false, because these elements of array A were not greater than 2, and 2 elements which are true. So we can perform, of course, all other math manipulations, which can be done through the math modules if we were working with numbers. But since we're working with arrays, we use the same functions, but of the NumPy module. So we can do NumPy square root of A, or we can do NumPy logarithm of A, or NumPy exponent of A, or let's say NumPy a sine of A. All right, we can actually do something which we wouldn't be able to do with the math module, with regular numbers. We can manipulate with numbers which are, well, not numbers. And NumPy has a special designation for that. It has a NaN thing. So let me show you an example, and then I'll explain a little more. So let's say I want to get my 1 divided by NumPy log of A. We can see that here for this element I have infinite, right? So infinity, which came from division, 1 divided by 0. So it didn't give me an error, it gave me a warning. Instead of crushing, I can still work with this result. Well, that was an example of infinity, and you can get an infinity if you divide something by 0, but if you, for example, divide 0 by 0, if I introduce array D, which is NumPy zeros like A, and then let's say I divide D by NumPy log A. So here, instead of infinity, I get these NaN, not a number. So these two things are defined in Python, in NumPy, by NumPy NaN and NumPy inf. What's convenient about them that you can actually check in your code whether the result of your certain mathematical manipulations is NaN or is it infinity. So I can do NumPy is NaN and check the result of my division D divided by NumPy log A. Well, Well, and it says true for these first element and false for the rest of them. Or I can do NumPy is inf for something like 1 divided by NumPy log a. And again, it shows true for this element, which was infinity, and false for everything else. And finally, we can check NumPy is finite, which would exclude both of these cases. So let's say NumPy log a. It says false for the infinite and true for everything else.